going to explain about the project title, Detecting Novelty Seeking from Online Travel Reviews, a Deep Learning Approach. Introduction. Online travel reviews play a crucial role in guiding travelers' decisions, providing insights into destinations based on others' experiences. The project focuses on understanding the personality trait of novelty-seeking NS within these reviews. Novelty-seeking influences tourism motivation and destination choices, as individuals tend to seek new experiences and adventures when traveling. Understanding novelty seeking aids both travelers and tourism organizations in aligning preferences and offerings. Manual classification of online travel reviews is challenging due to their sheer volume and unstructured nature. Analyzing numerous reviews manually becomes time-consuming, labor-intensive, and prone to subjective biases. The complexity increases when identifying nuanced personality traits like NS across various dimensions within these reviews. To address the limitations of manual classification, the project aims to develop an automated classification framework. Leveraging deep learning techniques, this framework aims to process and classify online travel reviews based on the presence or absence of NS traits. Automation helps manage the high volume of reviews efficiently, improving accuracy and reducing the time required for analysis. The proposed framework introduces a multi-dimensional approach to classify novelty-seeking personality traits within reviews. It segments novelty-seeking into 4 distinct dimensions: relaxation-seeking, experience-seeking, arousal-seeking, and boredom alleviation. Each dimension encapsulates specific behavioral traits and preferences expressed in travel reviews. The project employs a sophisticated deep learning model, BERT by GIU, to automatically recognize and classify novelty seeking from online travel reviews. BERT, a transformer-based model, processes textual data, while BiGIU, a bidirectional gated recurrent unit, refines the extracted features and patterns. This combination results in high precision and FN scores, indicating the model's ability to accurately identify and categorize novelty-seeking traits within reviews. Objective. The primary goal of the project is to create a framework that automatically identifies the personality trait of novelty-seeking NS within online travel reviews. This involves the development of a classification system leveraging deep learning models to efficiently recognize and categorize novelty-seeking behaviors exhibited in these reviews. Automating this process can significantly streamline the analysis of large volumes of reviews. Understanding the travel reviews are reflections of individuals' behaviors and personality traits. The project specifically hones in on 4 key dimensions associated with novelty seeking. These dimensions include relaxation seeking, desiring calm and tranquility, change from routine, seeking new experiences or novelty, arousal seeking, craving excitement, adventure or thrill, boredom alleviation, seeking relief from monotony or boredom. Analyzing reviews through these dimensions helps capture diverse aspects of novelty-seeking behaviors expressed by travelers. The project employs sophisticated deep learning models such as BERT, bidirectional encoder representations from transformers, and BiGIU, bidirectional gated recurrent unit. These models are utilized to convert the textual content of reviews into numerical vectors, enabling the extraction of relevant features crucial for detecting novelty-seeking patterns. BERT aids in understanding context and semantics, while BiGIU refines these features for accurate novelty-seeking detection. The ultimate aim of the project is to build a robust and automated system proficient in precisely identifying novelty-seeking behaviors within online travel reviews. This system serves multiple purposes, assisting individuals in selecting travel destinations aligned with their preferences and novelty-seeking traits, providing valuable insights to travel organizations, enabling them to comprehend demand patterns and tailor their offerings accordingly, streamlining decision-making processes in the tourism industry by automating the identification of novelty-seeking related behaviors, contributing to enhanced customer satisfaction and targeted marketing strategies. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of Wi-Fi and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. This step involves importing the necessary libraries and modules in the programming language that will be used throughout the project. Commonly used packages include Pandas for data manipulation, Seaborn and Matplotlib for data visualization, sklearn or TensorFlow for machine learning algorithms. Exploring the dataset. Here, the dataset is loaded and initial exploratory data analysis (EDA) is performed. This includes examining the structure of the dataset, checking for missing values, understanding the distribution of data, visualizing patterns, and gaining insights that will guide subsequent data processing steps. Data processing removes stop words, common words that typically do not carry significant meaning. Example, the and are eliminated from the text data. Applying stemming and lemmatization, techniques used to normalize words to their base or root form. Stemming involves removing prefixes or suffixes to obtain the root word, while lemmatization considers the context to transform words to their dictionary form. Vectorization, converting textual data into a numerical format suitable for machine learning models. This often involves techniques like TF-IDF, term frequency, inverse document frequency, or word embeddings like word-to-vector or GLOVE-VE. Splitting the data to train and test. The dataset is divided into two subsets, one for training the model and the other for evaluating its performance. Typically, this is done to assess how well the model generalizes to new unseen data. Building the model. The process of defining and constructing the machine learning or deep learning model architecture. For sentiment analysis or novelty detection in text, this involves recurrent neural network, convolutional neural network, or transformer-based models like BERT. Training the model. The model is fed with the training data and its parameters are adjusted to minimize the difference between predicted and actual outcomes. This involves an iterative process where the model learns from the data to improve its predictions. Comparison. Different models or variations of the same model are evaluated and compared based on predefined metrics, accuracy, precision recall, and FN score to determine which performs best for the specific task. Flask framework with SQLite for sign up and sign in. A web framework used for building web applications in Python. Flask allows the integration of backend logic and facilitates interactions between the user and the model. SQLite is a lightweight relational database management system, often used for smaller applications. It's likely used here to manage user authentication and storing user-related information such as username and password for sign-up and sign-in functionalities. User gives input, and the given input is pre-processed for prediction. When a user provides input through the front end of the web application, the input undergoes pre-processing steps similar to those performed during the initial data processing. Once the data is prepared, the trained model is used to predict novelty seeking from the user's input. Trained model is used for prediction. Final outcome is displayed through front end. The result of prediction generated by the model is then displayed to the user via the front end of the web application, providing a user-friendly interface to interact with the model's predictions. Algorithms used. In this project, we have utilized the following algorithms. LSTM, long short-term memory. LSTM is a type of recurrent neural network RNN architecture that's designed to handle sequence data by maintaining long-term dependencies. It's particularly useful in processing and making predictions based on sequences where context or temporal information is crucial. LSTM uses a gating mechanism to selectively retain and update information over multiple times steps, allowing them to capture long-range dependencies in sequential data such as text. BiGRU, Bidirectional Gated Recurrent Unit. BiGRU is another variant of recurrent neural network similar to LSTM but uses gated recurrent unit GRU. GRU are simpler than LSTM but still effective in capturing dependencies in sequential data. The bidirectional aspect means the network processes the input sequences both forward and backward, capturing information from both directions and potentially improving the understanding of the context within the text. LSTM plus GRU. In this case, a hybrid model is created by combining both LSTM and GRU architectures. The aim here is to leverage the strengths of both LSTM and GRU network to capture different aspects of the sequential data. By combining these architectures, the model potentially enhances its ability to learn and represent complex patterns in the online travel reviews. As an extension, we applied hybrid methods combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Comparison graph. Models are compared with the parameters accuracy, precision, recall, and FN score. This is the accuracy comparison graph. On the x-axis, we have the accuracy score, and on the y-axis, we have the algorithm name. Accuracy is a measure of the overall correctness of classification model. It calculates the ratio of correctly predicted instances, both true positives and true negatives, to the total number of instances. This is the precision comparison graph. On the x-axis, we have the precision score, and on the y-axis, we have the algorithm name. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions, true positives plus false positives. This is the recall comparison graph. On the x-axis, we have recall score, and on the y-axis, we have algorithm name. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is the FN comparison graph. On the x-axis, we have FN score, and on the y-axis, we have algorithm name. FN score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file, which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I am copying the path. Open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, which is this, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up. So here we need to enter all these details to register, but I have already registered, so click on sign in. So here we need to enter the username and the password which we have created and then click on login. So I have logged in successfully. So here we need to enter the message, and after entering the message we will predict whether the text type is novelty seeking or not. So here I am entering the message. So here I have entered the message. Now click on predict button. So here this is the message which we have entered, and the label for the message is the text type is novelty seeking. Now we will enter some more messages and check the text type. So here I am entering one more message now. This is the message which we have entered. Now click on predict button. So here we can see the message which we have entered, and the label for the message is the text type is non-novelty seeking. So in this way, by entering the message, we can predict whether the text type is novelty seeking or non-novelty seeking. Now click on sign out. The conclusion of the project is combining multiple deep learning algorithms in the project resulted in a significant enhancement of accuracy when predicting novelty seeking NS traits from online travel reviews. NS traits are essential in comprehending travelers' behavior and preferences. By leveraging various algorithms such as LSTM by GRU and hybrid models like LSTM plus GRU, the project aimed to capitalize on the strengths of each algorithm, leading to a more comprehensive understanding of the textual data. This amalgamation likely allowed the model to capture diverse patterns and nuances within the reviews, resulting in more accurate predictions of NS traits. Automated identification of NS behavior within travel reviews hold practical implication for both travelers and travel organizations. For travelers, this analysis can assist in choosing destinations that align with the preferences for novel experiences. It helps them find locations or activities that cater to their inclination towards seeking new and unique experiences during travel. For travel organizations, understanding novelty-seeking behaviors aid in making informed decisions regarding the development of new offerings, marketing strategies, and anticipating demand patterns. This knowledge enables them to tailor their services or products to better cater to the preferences of travelers seeking novelty. The success achieved through the hybrid model combining diverse deep learning techniques indicates potential avenues for further research and development. This suggests that integrating various deep learning architectures and ensemble methods can lead to improvements in accuracy and efficiency when analyzing behavioral patterns within textual data. It opens up opportunities for exploring new combinations of algorithms, refining ensemble strategies, and investigating the applicability of these methods in other domains beyond travel reviews. The success of this project paves the way for continued advancements in the utilization of deep learning for understanding nuanced behavior from textual data across various domains.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.